Welcome back to 3 Inquisitive Kids. I'm here to show you a problem that I came across recently on the internet. And basically, it's a geometric problem that's asking for the area of a specific shaded region. The problem says that quadrilateral ABCD is a square. So because it is a square, we know that the 4 side lengths are all equal. Point E is a point in the square ABCD. AE and BE are perpendicular at point E, and AE has a length of 10 units. So we're being asked to find the area of the blue shaded region, this triangle right here, ADE. There are 2 different methods when solving this problem. The first method incorporates something called engineer's induction. So what is engineer's induction? Well, it's a way of thinking when solving complicated math problems, especially geometric problems. It's basically when you're given a set of conditions, but the conditions have a little bit of flexibility so that you can take it and solve the problem under a special condition. How can we apply that in this problem? Well, in the question, it said that point E is a point in ABCD. That's a very vague condition because we're not really sure exactly where it is. It means that if it's drawn in this area right here, it could actually be anywhere, any single point in the square ABCD. So it should still be true if we moved it to a special place inside the square where all the calculations would be easier. Let me redraw the square. So this is square ABCD. And in this case, we're going to use an engineer's induction to place point E right in the middle. So this is the center of the square, and that's point E. Now, if we connect BE and AE to point E, they should still form a 90-degree angle. Now, the triangle AED, the one that we're trying to solve for, all we have to do is connect D and E, and we have the shaded region that we are looking for. And we know that AE has a length of 10. Because of this, we see that if we just double 10, since this here is also 10, we find the diagonal of the square, which is 20 units long. Now we can find the area of a square by squaring its diagonal times 1/2. So because its diagonal is 20, we do 20 squared times 1/2, which is equal to 200. So the area of the entire square is 200 square units. And because triangle AED is exactly 1/4 of the entire square, we take 1/4 of 200, which is equal to 50. So the final answer would be 50 square units. This right here would be the final answer. Now let's look at the second method. So here is method 2. And we're going to be drawing some auxiliary lines to help us with this problem. So as we can see, we're trying to find the area of a triangle, an obtuse triangle. And we have already been given the base of the triangle, which is 10. So when solving a triangle, we need 2 parameters, the base and the height. We already have the base, which is 10. Now we just have to find the height. Remember, the height is always going to be perpendicular to its corresponding base. So how can we find the height of this triangle, AED, by making an auxiliary line that is perpendicular to 10? Well, we can extend AE to point F, and then connect point F to D. And this will give us a right triangle, AFD. So AFD right here is a right triangle. Now let's observe AFD for a moment. Because sides AB and AD are the same length, because it is a square, they are congruent. Also, because angle AEB and angle AFD, so angle AEB and AFD are both 90 degrees, it means that they are congruent as well. Finally, we know that angles BAE and ADF are congruent, which means that the two triangles, triangle ABE and triangle ABE and triangle DAF, are congruent triangles. So what does this tell us? Well, we see that the shorter side of triangle ABE, right here, AE, is congruent to FD. So we know that FD and AE are congruent, which means that they're both 10 units long. And now we realize that we have found the height of triangle ADE. So because we have the height and the base of the triangle, all we have to do is multiply them and then divide in 2, giving us 50. So again, our final answer is 50 square units. Now, if you came up with any other solution of your own, feel free to share that in the comments down below. We're super interested in hearing what you have to say about this problem. So these two problems, the first one is engineer's induction. Well, this only works in cases where the problem isn't giving you a very, very specific condition. That is when you really have to pay attention to the conditions that are given and realize, oh, just because E is drawn like this in the square, it doesn't mean that it has to exactly be in that area. We could also move it to the center, for example. So engineer's induction can really help you find the pattern in special cases. Now, method 2 is when you, method 2 is a bit harder to grasp because you really have to think, oh, maybe I should extend AE to F in order to, find the height. But other than that, if you know how to prove that these two triangles are congruent, then it would be better because you could then prove that your solution was correct. Especially if this was a problem in which you had to prove your reasoning, then I recommend method 2. But in this case, method 1 was quicker. Thank you. So yeah, thank you for watching 3 Inquisitive Kids, and we'll see you in our next video.